everyone, welcome back to my channel. So this is going to be the second video of our blockchain development series. So in our first video we saw how blockchain works, why is it considered as a secure option to create and developing websites. So now we are going to dive a little bit further into it and we are going to see how smart contracts work. So after that video, if you have ever wondered about how all of these agreements and conditions are executing automatically without any intermediaries, then the answer is going to be the smart contract. We are going to develop and create our first smart contract program using Solidity programming language. Solidity is a programming language which is influenced by C++, JavaScript and Python. So if you know any of these programming language, then you'll be good to learn this Solidity programming language. So without any further ado, let's first understand what smart contract is. So, if I put it into the simpler terms, then smart contract is going to be the predefined and pre-programmed conditions that needs to be met every time we perform any transaction on our blockchain network. So, it is going to be a self-executing contract with the terms of agreements directly written into the lines of the code. So, it is going to be a computer program which automatically runs every time when someone does the transaction in our blockchain network. So beauty of smart contract is that they run on our blockchain networks, which makes them decentralized, secure and transparent. Okay, so let me give you an example. So for example, if you're buying a ticket for a concert from a seller, and if you want to buy it using a smart contract, then what are you going to do? You are going to pay 1 Ethereum to pay for the ticket. Okay, so seller is going to get the 1 Ethereum. If you send 1 Ethereum to the contract, the ticket is automatically going to send to your address. Okay, so if the seller fails to send the ticket after receiving 1 Ethereum, then you're going to get your money back. So everything happened automatically. You didn't need to trust the seller, or seller didn't need to trust you. In this way, the contract ensures both parties are automatically held accountable. There is no middleman or no disputes whatsoever. So before we start coding in our Remix IDE, there is one thing we need to discuss, and that is very important while we are writing the Solidity programs. There is a term called gas in every blockchain. So basically what it does is that it's going to measure the computational work for you, which will be responsible for all the interactions, like sending transactions, or either it's like interacting with the smart contracts. So basically it serves as a payment for the computational resources that is going to be required for all of our operations. So each operation in the smart contract will require a certain amount of gas, a certain amount of computational work, and that we are going to measure that with the gas. So for example, we are updating a state variable, or we are calling a function, so that is going to require a certain amount of gas, and that we will need to define in our programs. So gas limit we will have to define basically the gas limit, and that is going to define the maximum amount of gas that we can use, or maximum amount of gas that we are willing to spend on our each transaction. For example, if we want to perform a certain operation that requires 300 gas, but if we have set a limit as 200, it's not going to work, because it is requiring more computational power than what we have defined. So it is very essential, because it is going to prevent your network within the spam attacks, right? So if it is open source, without the gas, the millions of actors and malicious users are going to flood your network with the spam requests. So if you want to prevent that, you will have to set up certain gas limits, so that you will make sure that other users are not going to spam your blockchain. Okay, so now let's dive into the code. We are going to write our code in Remix IDE. So for that, you'll have to go to the Google and type remix.ethereum.org, and this is where we are going to create all of our smart contracts using Solidity programming language. Right now, we are going to deploy it in our test environment. So in this way, you'll have to make sure that you're not doing any real transactions as of now. So everything is going to be a dummy here, so test environment and also the test account. Let me show you what the environment should look like. So if you'll go to your Remix IDE, and when you'll click on here at the environments, you'll have to make sure that it's Remix VM. So this is basically the VM that Remix has created for the beginners, so that they can test their applications, and everything is dummy here. Even the account here is dummy. So you can select any of these accounts, that doesn't matter, and then it is going to do the transactions on the test network, so no real transactions are happening here. As we discussed, the how gas is really important while we are deploying smart contracts. So here it is going to create the estimated gas amount for your program once you select your program. Okay, so that was everything regarding the environments thing. Now let's start coding our smart contract. First of all, what you're going to do is you have to go to the contracts folder, and you will have to create a new file. There is a convention in Solidity programming language, especially in smart contracts, that you will have to put underscore here before naming any file. It's just a convention, how everybody goes about this. So I'm just going to write the name contract.sol. Okay, so now I have created my file. So very first thing you need to do here is you'll have to define what version of Solidity compiler you're using, right? So it is going to be 0.8.0. Okay, so this was the version of my compiler. Okay, and then the next thing you're going to do is you have to define the contract. So contract, the syntax of contract is very similar to of how we define classes in other programming languages like Java and C++. So similarly, we have to use a contract keyword, and I am going to name it greetings, because I'm going to create a program, like a very simple program, which will update the greeting string, greeting message, using set greeting function, and which can which will basically print the greeting message by using get greeting function. Okay, so for that you will have to first of all define the state variable, uh, which will which will declare the greeting string. Okay, so let's do that. String public greeting is equals to, so for now I'm just keeping it as hello G code. Okay, and that is going to be all for this. So this is a state variable, which means that its value is stored permanently on the blockchain, so no one can change this. And the next thing we'll have to do here is we have to write down the function set greeting. Okay, so function set greeting, if you have noticed, like it's very similar to JavaScript, right? And then string memory underscore new greeting. Again, you have to follow the convention that I just said. For now, I know it's not a good practice, but for now let's keep our writing function, like the set greeting function, as a public, and then I'm going to explain you how you can put the access controls in that. Okay, so new greeting, in this way we have allowed users to update the greeting, and it is also marked as public, so anyone can call it for now. Okay, and the next function we have to define here is the get greeting function. Inside our get greeting function, what do you have to do? Again, the same thing. This we are going to set it as public, and view returns string memory, and obviously we are going to return the greeting message, so just return greeting. Okay, so one thing, if you have noticed, we have put a view keyword here. So what does view keyword means? That means this function will only be available for writing. It does not have any permissions at all to modify anything in our code. So view permission, so basically all the read only functions uh, needs to be having the view keyword. Okay, and this was our for smart contract. Okay. um, I think we are missing something, and that is the, okay, so let's just specify the license identifier here. Okay. Now, yeah, yeah, in every code, just make sure you are specifying the license here. Okay. And now, once you have done this, you will have to go here on the left navigation bar, uh, click on the compile contract sol. Sorry. And then once you'll click here, you will notice that the compilation has been proceeded successfully. Okay. And if you will notice here, the log messages, it is going to say uh, how you can set up the inputs and how you can play around with the functions. This is not the true logs. Let me deploy this first. These logs are from the previous program that I was writing, so do not worry about that. So first of all, we will need to deploy this contract in this environment. So now, if as you can see from this, so this is our address, so like from my account to greetings.constructor value. So this means that this is deploying to this environment the greetings and like to this blockchain network and this function. Okay. And when you will click here, you can actually, yeah, so when you will click here, you will be able to set up your strings and everything. So let's say, using set greeting function, I am changing my string from hello jcode to just hello. So what I'm gonna do here is, I'll click on this arrow, I'll do the transact, and as you can see, it has been proceeded successfully. And it will show that from my account to the smart contract, and it is not going to show the value in the logs. It is going to show the hashed value uh, in the logs. Okay. And then when we click on get greeting function, we will be able to see what the string has inside. Sorry, when we will click on this get greeting function, we will be able to see what the user has set the greeting message. So as you can see, it is showing hello here. So because we have defined here public view returns, that means everybody will able to see the created string, whoever has the access or whoever has the address of blockchain network. Sorry. So there is one flaw in this code right now, which is what we are doing here. We have defined this function in public. That means anybody can come and tamper with our writing function, right? So we will need to make sure that we put access controls into the functions which are making modifications in our code. So in this function, we are making modifications in our input string, so that needs to be secured. So we will need to make sure that we put the access controls. For now, what I'm going to do, I will put an access control on this function such that only the admin should be able to admin should be able to run this function and should be able to change the string. Okay. And for that, first of all, what we need to do, we will need to define a constructor which will set the owner of contract. And how is it going to determine that who is the owner of contract? So so what is it basically going to do? Whenever this contract will be deployed, it is going to store the address who has deployed this contract. In this way, it is going to determine, okay, this guy has deployed this contract, and here is the address of this guy, so he's going to be the owner, and he will only be having the access to do anything with the set greeting function. Okay, so let's define that constructor, and inside that constructor, we are just going to say, okay, message dot sender. So in this way, it is going to determine that whoever is the sender of the message is the actual owner. So first of all, we also need to define the variable owner, or owner variable. So that is going to be address public owner. This is a state variable which is going to store the owner's address. Okay. And then one more thing we need to do is that we will need to create a uh, modifier which will restrict the access to owner. So it is going to be some sort of it's not a function, but it is going to behave like a function. We will use the modifier keyword here. Whenever this is going to trigger, whenever this modifier is going to trigger, it's going to check if the user is owner or not. That's the only thing it is doing. Okay, so modifier only owner, and then requires the message dot sender is equals to owner, and then we will also put a string here if in case it gets failed, that only the owner can update the greeting. Okay, so each modifier needs to be needs to be ended by this underscore and semicolon. Okay, so just make sure you're adding that. I think that's it. We have put our access control, into our smart contract. So the only thing now we need to do is that we have to call this here. So that's going to be everything. So now with this updated code, what is going to happen? Everybody will be able to see uh, everybody will be able to see what the string is by using this or by calling this get greeting function, but only I will be able to set up the input here. Before, the case was that we had a public function here included here, right? So before that, everybody was able to set up the new string and update it in our program, so which is not very ideal. So I will suggest you that every time you do, and every time you make any writing functions which is going to make modifications in a program, just make sure that it has a proper access controls, authentication, and permission checks included in it. Okay, and there is one more thing. There's one more thing I'll need to point out is that the one great thing about smart contract is whenever we are creating a function, once it is created, no one will be able to change how the function works. Even if it is me, even if I'm the owner, I won't be able to change the way how the function works. So in this set greeting function, what I'm basically doing, I'm setting the message, whatever the message is, equal to the message that we have defined in public greeting variable, right? That is the main logic or functionality of the function. Nobody will ever be able to change that, even if it's me or someone else who has the doesn't matter what kind of privileges or what kind of access they have for the smart contracts. So that is really a great thing. If you want to change any functionality, you just have to upgrade your contract, or maybe you'll have to create a new contract. So I think that was everything from this for this video. This was our first smart contract program, where we have defined how things work, how we can put the access controls to make sure we are doing everything in a secure way. So thank you so much for watching, and that was everything for this video.